All right, let's dive into something pretty wild today. Imagine, right, you wake up, look in the mirror, and boom, brand new liver, like it was just delivered.
Next day delivery for organs. That's the dream.
Well, it's getting closer to reality than you might think with this whole bioprinting thing.
It's true, and it's not just sci-fi anymore. We've got companies, Organovo, BioLife 4D, they're out there making actual headway, printing tissues. It's incredible.
So for folks who haven't tumbled down this rabbit hole yet, we're talking building organs, like from scratch, cell by cell, printers, but not the ones spitting out your emails.
Yeah, think 3D printing, but instead of plastic, it's your cells. They make this bio ink, see? It's like this super precise recipe, your cells in this gel, and the printer, it lays it down layer by layer.
So no more waiting for someone else's tragedy to maybe get a transplant. No more rejection issues because it's literally made from you.
You're getting it. And it's already happening, in a way. Mayo Clinic, they're doing skin grafts for burn victims, bioprinted. It's amazing.
And that's wild. So maybe a full heart is a bit off, but we're on the way.
We're getting there. Labs are printing little mini livers, kidneys, proof of concept stuff. It's like the first few wobbly steps before you're running a marathon.
Okay, so organ transplants, huge. But where does it go from there? Are we just fixing what breaks? Or can we, like, soup up the human body with this tech? It's weird, right? We talk about feeling younger, but imagine actually having better organs than you did even as a kid.
It's wild when you think about it. Like, what if your organs didn't just get replaced? They got a serious upgrade.
Instead of hoping your old heart sticks around, you get one that's, like, immune to problems. That could be bioprinting's future.
Totally. And not just immunity. Imagine efficiency, organs that just work better. Scientists are already figuring out how to build that into the design, even at the bio-ink level.
So we're not just living longer, we're talking about those extra years being healthy, high-performance years. But is there a limit? Could we outrun aging itself?
That's where this longevity escape velocity idea comes in. Every tech leap, we're chipping away at aging's lead. What if we start sprinting faster than it can catch up?
Longevity escape velocity. Sounds like a rock band name, but man, with bioprinting, the future's getting really weird, really fast. In a good way.
And don't forget about AI. That's huge here, too.
Oh.
It's not just printing. It's analyzing your body's data, personalizing that organ, so it's not just an organ, it's yours.
Hold on, so my custom-made liver, designed by an AI, sign me up. That's way better than any loyalty program. It's like having a microscopic pit crew for your own body, constantly optimize it.
You got it. And that might not even be the end of it. What if we go past fixing, past upgrading, and start making entirely new stuff? Bioprinting, that's basically human 2.0.
Okay, now that's some next-level stuff. We're getting into some serious sci-fi territory here. We're right back after this quick break to explore those possibilities. Don't go anywhere. All right, we're back and ready to dive into the deep end of bioprinting. Before the break, we were teasing the idea of going beyond just fixing what's broken, of using this tech to enhance ourselves in ways we can barely imagine. It's exciting, but it also feels like we're stepping into uncharted ethical waters.
It's true. The possibilities with bioprinting are as profound as they are potentially challenging. So far, we've talked about replacing or enhancing existing organs, but what if we could create entirely new biological structures? Imagine bioprinted organs with capabilities that go beyond anything found in nature.
We're talking about moving beyond the limitations of the human body as we know it, right?
Yeah.
The source in the Journal of Medical Ethics called them designer organs. It's like we're designing the next generation of human evolution.
That's a powerful way to put it. We could be on the cusp of a new era where humans are not limited by their biology. Imagine organs that enhance not just our physical capabilities, but our cognitive functions, sensory perception, maybe even our creativity.
Okay, now that's a future I want to live in. But with all this talk about enhancing ourselves, we have to ask, what are the implications? Will everyone have access to these advancements, or will it create a divide between those who can afford to enhance themselves and those who can't?
That's the million-dollar question, isn't it? As with any powerful technology, ensuring equitable access and responsible development is paramount. We need to carefully consider the potential societal impacts and establish ethical guidelines for this technology to benefit all of humanity.
It's like we're holding the keys to a future filled with incredible possibilities, but we need to make sure we're using those keys responsibly.
Well, that future might be closer than we think, thanks to 3D bioprinting. And you're in the right place to unpack all that, because we've got a whole stack of research right here ready to deep dive with you.
Yeah, let's do it.
We're talking cutting-edge stuff here, 3D bioprinting, the future of regenerative medicine, studies from the Mayo Clinic, the World Economic Forum, even a paper called Get This 3D Bioprint Me.
3D Bioprint Me. Catchy.
Right. So we'll tackle the how, but also the whoa of this tech that could, like, totally reshape medicine as we know it. But first, gotta start basic. What even is bioprinting? Like, in a nutshell.
Okay, so picture a regular 3D printer, but instead of plastic, it uses these bioinks. They're like high-tech cocktails of living cells.
Cellular cocktails, I like that.
Right. Packed with all the good stuff cells need to, really thrive. Instead of just a boring petri dish, it's like giving them a perfectly built tiny apartment building.
Okay, I'm getting a visual here. So this printer lays down these bioinks layer by layer, following a blueprint, and boom, 3D structures that are like real tissues.
You got it. And there are different ways to do it. Extrusion bioprinting, which is like your classic desktop 3D printer, squeezing out the bioink. Then there's inkjet bioprinting, using tiny precise droplets. Think your desktop printer, but way, way more precise.
Okay, I follow. More precise because, cells.
Exactly. And then we get to the really cool stuff, laser bioprinting.
Lasers. Okay, now you're talking.
Right. This one uses lasers to basically place cells and materials with mind-blowing accuracy. Like, we're talking building crazy complex tissue, stuff we could only dream of before.
So different printing methods, got it. But what about the ink itself? What's actually in these bioinks?
Oh, it varies. We're talking everything from collagen, like in your face cream, to these super high-tech, futuristic hydrogels that like perfectly mimic natural tissues. Really depends on what specific tissue we're trying to build.
So choosing the right building material for the job makes sense. But inside that bioink soup, you've got the living cells themselves. How do you keep those guys from kicking the bucket when you print them?
Yeah, that's the million-dollar question, right?
Yeah.
Huge challenge. It's like keeping a super picky plant alive. Needs the right food, the right temperature, you name it. And then those cells don't just need to survive, they need to thrive, multiply, actually function together as a tissue.
Not as easy as hitting print on a new kidney, I'm guessing.
Not quite yet, but we're getting there. And the potential is, well, let's just say, it's pretty mind-blowing. I mean, one area that's super interesting is, get this, bioprinting in space.
Hold on, in space, like actual outer space, you're messing with that, right?
Totally serious. Sounds crazy, but there are some really good reasons for it. Think about, like, mission to Mars, something long haul. If an astronaut has a major organ problem, you can't exactly just, like, turn the spaceship around.
Okay, that's true. Deep space transplant is not really an option. So you're saying being able to bioprint a new organ right there on the ship, that could be a game changer.
Exactly. Life or death, even. But it gets cooler. Microgravity, being practically weightless, it changes how cells grow. Scientists think we can use that to our advantage.
Wait, you mean we could print even better organs in space than back here on Earth?
That's the idea. Still early days, but the research is promising. They've already printed heart muscle on the International Space Station, and the cells organize, like, way better in that environment.
Wild. So maybe space organs before flying cars? Who knows? But back down here on Earth, I keep seeing this other application using bioprinting for making new medicines.
Right. Huge potential there, too. Like we were saying, imagine testing new drugs on bioprinted livers instead of on animals.
Which, ethically speaking, is a huge win. But it's not even just that, is it? It's about getting more accurate results, right?
Exactly. Animal testing, it's helpful, but it's not always a perfect predictor of what will happen in a human body. But if you're testing on human cells, bioprinted tissue, we get a much clearer picture of how that drug's actually going to work.
Makes sense. Safer drugs, fewer side effects. You get those treatments to people who need them way faster.
Exactly. Revolutionize how we treat everything. Cancer, Alzheimer's, you name it. Researchers are already testing chemo drugs on bioprinted tumors. Imagine the possibilities for personalized treatments.
Okay, so we've got on-demand organs, maybe even like superhuman organs, revolutionizing medicine. This all sounds a little too good to be true, which makes me wonder, what's the catch? What are the downsides here?
That's the thing, right? Anything this powerful, this new, you got to be cautious, ask the tough questions.
Okay, so tough questions time. What are the challenges, the things we need to watch out for with bioprinting as it grows?
Well, one of the biggest ones, making sure this tech helps everyone, not just a select few. Imagine if these bioprinted organs are a reality. We can't have a system where only rich people can afford them.
Right, so no two-tiered healthcare where your bank account determines if you get a life-saving treatment.
Precisely. Equity's going to be huge. And then there's regulations, right? This field is moving so fast, we need to make sure it's developing safely, ethically.
So we don't end up with some black market for organs, unregulated labs churning out who knows what.
Exactly. We
Yeah.
got to be thinking about these risks now, even while we're excited about the potential.
A real tightrope walk. Right. Embracing the good, acknowledging the bad. Not easy.
Nope. But it's a conversation we have to have. Because this is the future of medicine, literally being shaped right now. We all have a role in making sure it's a good one.
I don't know about you, but I feel like we're like peering into the future here. All this potential, but also these big questions, ethical stuff, a lot to process.
Yeah, no doubt. But that's what's so exciting, right? We're not talking about just like small steps forward. This is a whole new way of thinking about medicine, about our bodies even.
We've definitely covered a lot of ground today. How bioprinting works, solving the organ shortage, new medicines, even like making our bodies better than they were before.
We even went to space.
Don't even get me started on space organs. Still wrapping my head around that one. But I feel like I get it now, you know? Bioprinting, what it is, what it could do.
And you're asking the right questions. That's key with any new tech, especially one this powerful. Got to stay grounded.
Always. But there's this one thing I kind of asked. It kept popping up in the articles. 4D bioprinting. What in the world is that? It sounds like something out of like a time travel movie.
4D printing. That's where things get really wild. Okay, so imagine regular bioprinting is like taking a single photo, a frozen moment. 4D printing, it adds in time.
Okay, I'm listening. So not just printing a 3D organ, but one that like changes over time.
Exactly. Designing structures that react, that adapt to what's around them. Imagine an implant that literally grows with a child. No more surgeries every couple of years. Or tissues that, like, reform themselves to heal damage.
That's insane. So it's bioprinting, but with a fast-forward button.
Perfect way to put it. It opens up a whole new world. Treatments that are not just for you, but for your body at that exact moment.
So we're talking replacing organs, healing ourselves, personalized medicine, maybe even pushing the limits of what our bodies can even do. Bioprinting, it's really like the future of medicine, isn't it?
It really seems that way. And yeah, we got to watch out for the downsides, be ethical, all that. But honestly, how can you not be excited about this? The potential is just incredible.
It's happening right now in labs all over, people working on this, breakthroughs every day. Who knows what's coming next? And on that note, folks, we've reached the end of our deep dive. Bioprinting, from the basics to the totally mind-blowing, we covered it all. This is one to watch, so keep your ears open, stay curious, and as always, thanks for exploring with us.